Dear AS or A-level students, hi everyone again, and I hope you are well in these circumstances that the whole world is in. I wish you the best in all cases. We are finishing, my dear students, the chapter of dynamics in M1 at Excel or Cambridge, which is momentums, which is the momentum. We'll be starting, before we start doing examples, and we have to define some quantities before we start. What does a momentum mean? What does the momentum equal to? The momentum of a particle is the product of its velocity and its mass. If a particle moves with velocity v, if mass m kilograms, then the momentum of the particle is the product of its mass times its velocity. Since the unit of the mass is kilogram and the unit of the velocity is meter per second, so the unit is kilogram, one of the units, we know that v is equal to a times t. So we may represent the momentum as MAT, which is FT, since F is the product of MA. Since the unit of force is Newton, so we have other unit or another unit which is Newton second. Newton second. If we act on a particle by horizontal force or force in general, F Newton, for t seconds, we define the impulse of a force or of the force of the particle that is represented by I as the product of the force times t. So the impulse of a particle is the product of the force and the time in seconds. Newton second. So the unit is Newton second. As we know before, the acceleration is the change of velocity per time. So if you replace a by its value, v minus u over t, final velocity minus initial over t, by cancelling t by each other, t over t is 1, you'll be getting I, the impulse, which is ft, is equal to mv minus mu, where v is the final velocity and u is the initial velocity. That is called final momentum minus initial momentum. So what do you call this? Change in momentum. This is called change in momentum. Change in momentum. The impulse is equal to final momentum minus initial. Final momentum is the final velocity times the mass. Initial momentum is the initial velocity times the mass. That gives us at the end impulse is equal to mv minus mu. We have to know that the impulse is the one of the quantities as vectors, since mass is a scalar, and the velocity is a vector. By putting m as a common factor, you'll be getting m times the difference in velocities. So scalar times vector in mathematics is a vector. So that means that I must state or describe the direction when I solve the problems on momentums. Let's do some examples, different examples. Example number 1, which is one of the questions in the exercise, which is question 1. If some of you are studying from Excel or for Excel for M1 textbook, it's question 1, the exercise 3G, page 68. Question says, A ball of mass half kilogram is at rest. When it is struck by a bat and receives an impulse of 15 Newton seconds. Find its speed immediately after it is struck. The most important step, we said, we write usually in mechanics the given information. So you are given m is half, u is 0, it's at rest, v that he wants, and the impulse is 15 Newton seconds. By writing the formula of impulse momentum principle, this is called impulse momentum principle. I is equal to mv minus mu, impulse momentum principle, that the impulse is the change in momentum. Then only one step, that I replace the values, each quantity here by its value. I is 15 is equal to half times v that we want minus half times u. U is 0 since the particle is at rest. So 15 is equal to half times v. So v is equal to 30. 15 times 2 or 15 dividing by half by calculator, you will get v is equal to 30 meter per second. This is a straightforward example we start with. Let's see how some other questions may come in the exams. Example 2. A ball of mass 0.2 kilogram is dropped from a height of 2.5 meters above horizontal ground. After hitting the ground, it rises to a height of 1.8 meters above the ground. Find the magnitude of the impulse received by the ball from the ground. It's one of the important questions. Find or calculate the magnitude of the impulse received by the ball from the ground. Since, my dear students, I'm just sketching you quickly in a few seconds, since the particle was above the ground for a height of 2.5 meters, dropped from rest, and the ball hits the ground and rises again. So we have stages of motion. We have to do steps, step by step, to find what does he want. What does he want? He wants the impulse from the ground. I'll do this in different, from the ground, on the ball. So we must find u and v here, my dear students. We must find u and v here in the last part of motion. To do this, what I must do, I must do the question in stages, in steps. Step number 1. We know the height that the ball is dropped from 2.5 from the ground. So we know the height. We know that when it's dropped, so it will be accelerating with 9.8 with positive. So the acceleration is g, which is 9.8 meter per second squared. Since it dropped, so from rest, so u is 0. So we know u and g and h. He wants what? He didn't say find v, but we have to know by ourselves what must we find to calculate the impulse that he wants. So he must find first v, the velocity. I must find first the velocity when the ball hits the ground. when the ball here hits the ground, which is V. Which is V, using the formula V squared is equal to U squared plus 2GH. So V squared is equal to 0 squared plus 2 times G, which is 9.8, times 2.5, which is the height, is equal to 49 with the calculator. So V squared equals 49. So V is equal to 7 meter per second. V is equal to 7 meter per second. Step 2, stage 2 now. Stage 2, after it hits the ground, the ball hits the ground now. The ball is here. It rises again. Now the ball rises. The ball rises. So we don't know its speed when it rises again from the ground. From the ground. So we need the velocity when the particle or the ball hits the ground, rises again. So we need the velocity now when the ball rises again to 1.8 meters. What will happen here? When it rises again, we don't know its speed, so we have to find U, which is the speed when it rises again. When it goes up now, so the acceleration is minus G, minus 9.8 meter per second squared, reaching a height of 1.8 meters. So velocity is 0. The velocity is 0. When he said to 1.8 meters here, above the ground, we understand that the motion is finished here. So V is 0. So by replacing now in the same formula, V, which is 0 squared, is equal to U squared that we want, plus 2 times minus 9.8 times 1.8. So this times this by calculator 35.3. So U is equal to 5.94 meter per second. What did we find till now, dear students? We find now. Now we are finding. We have found the ball when it goes down, dropped, reaching, hitting the ground. Here it was 7 in this direction. When it rises again, which is 5.94 meter per second. What does he want here? We said direction is important. Stating the direction in these questions is very important. So the impulse from the ground on the particle is this on the ball, this direction. So I that I'm calculating is this direction. So now this happened first, and rising again up happened after. It was dropped, then rising. So the last stage in the solution, this is U now, 7 is U now, and this is V now. Got it? So again, now this was the first stage of motion. When we dropped, this is dropping, hitting the ground with 7 meter per second. Then the ball was going, it rises up. So this is the last part of the motion in this question. So this 5.94 is V now, and 7 is U now. Easy, making common sense. So by using the formula or the principle, impulse momentum principle, I is equal to mv minus mu, I have to pay attention to the direction here. I have to consider the direction. So the direction of the impulse is this direction. So V, which is this, in the direction of the motion. So it is the positive one. Because the direction of the impulse from the ground on the ball is up. And this direction is up. Minus from the low, 0.2, which is the mass, times -7, because this is opposing the direction of the impulse that he wants. Because of this, we put -7. -7. By replacing 0.2 times 5.94 minus 0.2 times -7, you will get the impulse is 2.588 Newton second from the ground on the ball. From the ground on the ball. This is one of the ideas may come in the exams. Of course, in the next part we'll finish this for now for a few minutes. Be moving for the next part to not make this lesson very long. So I divided it into two because it took time, like more than 40 minutes. It will take a long time, so I divided this lesson into two lessons. Momentum 1, which finishes with this example. They will be moving next lesson for momentum 2. For momentum 2, which is what does collision mean, impact, and conservation of momentums, and so on. So the last example for today about momentums. A toy car of mass 0.2 kilograms is pushed from rest along a smooth horizontal floor by a horizontal force of magnitude 0.4 newtons for 1.5 seconds. Find its speed at the end of the 1.5 seconds. Good. The most important thing is to write the given quantities, the given information. We are given the mass. The mass is 0.2 kilograms. Since it is pushed from rest, so U is 0, by a force of 0.4 newtons for time 1.5 seconds. He wants the speed at the end, so he wants V. By writing Ft is equal to mv minus mu, just by replacing the values. This is the idea in this question. By replacing or substituting the values given in the question, F is 0.4, T is 1.5 seconds, M is 0.2 times V minus 0.2 times U, U is 0, so this is 0, so 0.4 times 1.5 is 0.6, dividing by 0.2, you will get V is 3 meters per second. This is the velocity or the speed of the particle or the toy car at the end of 1.5 seconds. I hope this lesson was simple and easy. Read it again. And if you have some issues or problems with this, it will be explained, covered in the next part. Next part will be continuing with momentums, but in two particles, when two particles collide. But we'll be doing past paper problems in the second part for you to have a clue how the questions may come. We'll do easy or fair questions and harder ones. As usual, I wish you the best.